Next one is comprehension. 20 ml of m by 60 1 by 60 molar solution of KBrO3 potassium bromate was added to a definite volume of selenate solution. The bromine evolved was removed and excess of KBrO3 was back titrated with 5.1 ml of m by 25 solution of sodium arsenite. Reactions involved are given. So SeO3 2 minus reacts with BrO3 minus in H plus, that is acidic medium, to give SeO4 2 minus bromine water. And second equation is the bromate is then treated with arsenite solution to give bromide, and arsenate H plus is given out. Atomic weights of atoms of the elements are given. Then what are the questions given? Question 1. What is the amount of selenate in solution? Approximately 24 milligrams, 36 milligrams, 64 milligrams, 84 milligrams. So when we look into the equations and the comprehension given, the first equation is SeO3 2 minus plus BrO3 minus and H plus. Br2 is liberated. So let us take the balanced form of the equations. Whenever equations are given, it is always convenient to work with moles or millimoles. When equations are not known, it is better to work with equivalents or milliequivalents. So since equations are given, let us work with respect to moles and millimoles. So we are using 20 ml of m by 60 solution of KBrO3. Therefore, 20 ml of m by 60, that is 1 by 60 molar, that is 1/3, 1 by 3 millimoles of KBrO3 was first added, and the bromine evolved during this reaction is removed, and the excess of KBrO3 was back titrated. So the question is on back titration. For weight purpose, 5.1 ml of m by 25 solution of sodium arsenite is required. Therefore, 5.1 ml of m by 25, that is 1 by 25 molar solution. So nearly, since in the question also approximate being there, let us take this is nearly 5 ml. So 5 ml into 1 by 25, 1 by 5 millimoles approximately. Of what? Sodium arsenite is consumed. NaAsO2 is consumed for leftover potassium bromate. For this much amount of sodium arsenite to be consumed, what millimoles of KBrO3 is left over? So let us consider first the second equation, where we are given the equation as bromate BrO3 minus reacting with arsenite AsO2 minus in solution. Water is the solvent. To give what are the products of the reaction given? Bromide Br minus and arsenate AsO4 3 minus plus H plus. So on balancing this equation, we get 1 mole of bromate reacts with 3 moles of arsenite in the presence of 3 moles of water to give 1 mole of bromide and 3 moles of arsenate and 6 moles of H plus. From where we can understand that every 3 moles of arsenite being consumed, there will be 1 mole of bromate left over in the solution. But here, as per the second step, we have 1 by 5 millimoles of sodium arsenite is consumed. Say 3 millimoles, 1 millimole is left. For 1 by 5, how much is left? Therefore, for every 3 millimoles of arsenite being consumed, 1 millimole of bromate will be left over. How much is consumed? 1 by 5 millimoles. How much is that? So this corresponds to 1 by 5 by 3. That is 1 by 15 millimoles of bromate is left. So the total used is 1 by 3 millimoles of KBrO3. Out of that, 1 by 15 is left over. So how many millimoles of KBrO3 is actually used up? That is 1 by 3 minus 1 by 15. Therefore, number of millimoles of KBrO3 left over after the reaction is 1 by 3 minus 1 by 15. That is equal to 15, 5 minus 1, 4 by 15. But these are the number of millimoles of KBrO3 consumed by selenate. So now what we have to see is the other reaction. How does selenate SeO3 minus 2 reacts with BrO3 minus in acidic medium to give selenate SeO4 2 minus plus bromine plus water. Now what is the balanced form of this reaction? So here in selenate we have plus 4 and here it is plus 6, 2 is to 3. That is increase is 2. Here in bromate we have bromine in plus 5 state. Here it is 0. So it is 5. So now 5 will come here, 2 will go here. So thereby 5, 2. When 5 seleniums are there, this is 5. 2 bromines are already there. So how many H plus to balance it? 2H plus to give H2O. So this is the balanced equation. From where we can understand that for every 2 moles of bromate to be consumed, there should be 5 moles of selenate. So how many millimoles of bromate consumed? 4 by 15. So every 2 millimoles of bromate to be consumed, there should be 5 millimoles of selenite, SeO3 minus 2. But actually consumed is 4 by 15 millimoles. That is 4 by 15 by 2 into 5. So 5 ones, 5 threes, 2 ones, 2 twos, 2 by 3 millimoles of selenite is there. This corresponds to what weight in milligrams. Therefore, weight in milligrams is, so 2 by 3 already millimoles into molecular weight of SeO3 minus 2, which from the atomic weights of selenium given and oxygen comes out to be 127. This is nearly 42 into 2, approximately 84 milligrams. So directly we have taken in milligrams because this is millimoles. So therefore the answer is 84 milligrams. Do we have that option? So here is the D answer.